In this lesson, we'll learn about rotary position milling. After completing this lesson, you'll be able to use tool orientation and create roughing and finishing toolpaths. In Fusion 360, we want to get started with the supplied dataset 3 plus 1. We're going to navigate to the manufacturer workspace. We're going to change our units to inch and begin creating a new setup. For this part, we want to expand our models and we want to expand the bodies folder, and note that we have a stock body. So for our stock, we're going to set this to from solid and use our stock body. For the coordinate system, it's important to understand whenever we're adding a fourth axis or an A-axis to a machine, this is going to be rotating about X. If you have a different setup or a different orientation on your machine, then you need to make sure that it's set up based on that. But for our example, we're going to assume that our A-axis is rotating about X. So in this case, whether it's on the left side or the right side of the table will determine whether or not X is pointing away from the part or into the part. For our example, we're going to assume that X is pointing away from the part in this orientation, as if the fourth axis is mounted on the left side of our table as we're looking at the machine. From here, I need to make sure that my Z and my X are in the correct orientation. So right now, I need Z to be pointing opposite of X. I'm going to do this by holding down my left mouse button over X, and then I'm going to flip my Z axis. Once again, I need to make sure that X is pointing the right direction. So for X, I'm going to select the default Z axis, and then I need to make sure it's in the correct orientation as well. So this is going to be at the center of my part at the far right-hand side, again based on the orientation that I'm assuming. From here in my post-process section, I'm going to add a comment of 3 plus 1, and I'm going to set my WCS offset to 1, which represents G54 on my machine. I'm going to say OK, and now that I have my coordinate system set up, I can begin programming. When we're taking a look at 3 plus 1 programming, what we're doing is we're rotating the part a specific amount, and then we're using our traditional 2D or 3D toolpaths. So for this example, we're going to start by using a 2D pocket. Typically, when you start a 2D pocket, you first select a tool. We're going to go into our multi-axis tools and select tool number 6, which is our 1/4 inch flat, and use it on aluminum roughing. Once we have our tool selected, we generally would come in and begin selecting some geometry. You'll notice that when I try to select a chain, it's going to be based on the current tool axis, which is positive Z. So I need to start by setting my tool orientation relative to this face. So I'm going to select the face for Z, but note that X is not in the correct orientation. It's based on our setup WCS in terms of its location, but X really needs to be pointing away based on the default coordinate system. So you see here, what we're going to be sending the controller is going to be a rotation about A. It's going to give it an A-axis degree rotation, which means that when I'm setting up my tool orientation, I must represent the movement of my coordinate system based on that rotation at the center of my part. Now that I have that selected, I can come back and select the face that I want to machine. I'm going to assume that this is not only a roughing but also a finishing operation, so I'm going to not leave any stock behind, and I'll say OK to create my toolpath. Whenever we're dealing with these 3 plus 1 or this multi-axis positioning, what we really want to make sure we understand is that process of setting up the tool orientation. Because we've already done that, I can right-click on my 2D pocket and I can create a derived operation for something else that I need to do. For example, a 2D contour. From here, I need to select an appropriate tool. For us, it's going to be our tool number 11, chamfer mill. And then I want to select my geometry. Now, by default, when I derived it, it automatically brought in those chains, but note that the coordinate system for my tool is automatically set up. I'm going to select the lower edge of these chamfers, and then I'm going to go to my passes and note that I have a chamfer option. I'm going to leave it at 0 and say OK, and allow it to cut those chamfers. Now, since I selected a chamfer mill, it gave me those additional options in the 2D contour. I could also use a 2D chamfer mill operation Either would be just fine, but in this case, a 2D contour is fine because there's really no other geometry I'm worried about colliding with. So I'm going to just simply use the 2D contour with that chamfer option. I am going to add a small amount of tip offset, allowing the tool to come down just a little bit farther to make sure that the end of the tool is slightly below that edge. So this is a quick orientation in setting up our tool for a multi-axis position. Now, once again, the important considerations here are to understand the location of the coordinate system and its orientation. We need to make sure that with this fourth or A axis that we're rotating about X. The orientation of X on your table is going to be based on the position of this fourth axis as it's added. So in my case, again, I'm assuming that it's on the left side of me as I'm looking at the machine. So X plus is pointing to the right. This is extremely important that we understand that coordinate system setup, as well as the fact that our tool orientation must be represented in that coordinate system shift. We're only rotating about X. We are not changing Y. It has to be in the same orientation because that's what's going to get sent to the controller. Once we're done setting up this first 2D pocket and 2D contour, let's go ahead and save the design so we can move on to the next step.